Okay, let's go ahead and start off by taking a look at logarithms. Okay, because we've just finished the exponentials unit, and we're going to spill over into logarithms because they are related to each other. Now, let's go ahead and just make sure that we have an idea of what they are first. First of all, logarithms are just numbers. Okay? That's all that they are. It's just another way to express a number. Now, why are they needed? The reason why they're needed is because there are times when you're going to need to solve an exponential equation that does not have a common base. Now let's take a look at this example. This example was a very simple example because we said before that so long as we can actually find a common base, then all we need to do now is compare the exponents. So therefore, x has to be equal to 3. Now, what if that common base cannot be found? Say, for example, we have something that looks like that. If we have this kind of situation, we still need to be able to find the exponent such that when I take 2 and raise it to that exponent, it is actually going to give me 9. And there is a number that does that, and that number is a logarithm. Okay, so let me just go ahead and make this very, very important statement about the relationship between exponential equations and logarithmic equations. Okay? All exponential equations, mean that we're familiar with them now, something like this, have an equivalent logarithmic form. Okay, before we actually go ahead and take a look at what that means in terms of the exponential and the logarithmic forms, let's go ahead and take a look at something that you've already been doing quite often, because this is the exact same concept. Here you have x to the third is equal to 8, and you have x is equal to the cube root of 8. I'm hoping that everybody recognizes that these two right over here are equivalent forms. One has the power, and the other has the root. Okay. Let's take a look at this. It says sine x is equal to the square root of 3 over 2. This one says x is equal to the inverse sine of the square root of 3 over 2. Those two statements here are equivalent statements. They mean exactly the same thing. Same thing here, which is a very much more simplistic one. It says x plus 5 is equal to 6. That is equivalent to x is equal to 6 minus 5. Now, what I'm hoping that all of you notice is that what I'm doing basically is I'm just taking the inverse, right? I'm taking the inverse and trying to find out what the value of x is in each one of these cases. Now, before we actually go ahead and take a look at how that applies to exponentials and logarithms, let me show you what the equivalent forms look like. Okay, everybody agrees that 3 to the 0 is equal to 1. The equivalent logarithmic form of that is log base 3 of 1 is equal to 0. These two are exactly the same. They mean exactly the same. It's just that the way that they're written is different. It's just like these two. They're exactly the same. It's just that the way that they're written is different. Okay? So let's take a look at this one. Right? 3 squared is equal to 9. That is equivalent to log base 3 of 9 is equal to 2. Okay, so again, all of these here are examples of how I can take an exponential equation and find its logarithmic equivalent. Okay? Now again, remember that one of the reasons for doing this is because we sometimes have to find out what this value is. Okay, and let me show you how we can actually go ahead and do that after I explain this small bit here. It says in general, if a is equal to b to the x, notice that we're dealing with an exponential function, then the log base b of a is going to be equal to x. Okay, where a is going to be greater than 0 and a is not equal to 1. Okay, so let's go ahead and take a look at an example now. Let's say, for example, that I take this and I apply it to this, because basically what I'm trying to do is I'm trying to find out what a logarithmic expression is for this. So if I was to do that, notice that the a is the 9, right? The b, which is the base, is 2. And of course, the x value is right there. Now, the equivalent logarithmic form of this equation is log, what is the base? The base is 2 of the value of a, which is 9, is equal to x. Okay, so remember what we were saying is that we wanted to actually go ahead and find out what exponent is actually going to change 2 to the x to be equal to 9. There it is. That number put into the exponent position here with 2 as its base is actually going to give you 9. Okay, so again, it is a number because it's the exponent, it's just a number to help us solve for exponential equations that do not have a common base. Now let's go ahead and take a look at another example here. Let's say, for example, you have 2 log base 2 of 16. What is this equal to? Okay, so I'm not exactly sure, so let's just go ahead and say that that's x. Now, of course, I'm not familiar with this logarithmic form. So what I can do is, let's go ahead and change it to its equivalent exponential form. And so what we come up with. Now, this is what we're starting off with here. The log base 2 of 16 is equal to x. So we need to go ahead and change it then to this form here. And if that's the case, then we're going to say that 16 then is going to be equal to 2 raised to the x. Okay, if that's the case then, now we can use our normal means of actually finding out what this value is by making sure that the bases are common. And we know that this is going to be 2 to the 4th is equal to 2 to the x. So that means that 4 is equal to x. So that means then that log base 2 of 16 is 4. Okay, so again, this is a number. Okay, it is a number. So, although I think most of you do not have any experience working with logarithms, in the same respect when before you had no experience working with cube roots and no experience working with inverse sine, by practice you'll be able to understand it and see its relevance as well, and hopefully be very confident with it so that you can solve any exponential equation. Okay, so let's see how this works out. We'll take a look at a lot of examples in class, and let's give it our best shot. Okay, see you next time. Bye.